Okay, so let's say that our goal is to graph, is to use, sorry, let's say that our goal is to graph y equals x squared. Now, the first thing that I want to point out, the thing that when we look at the plot stuff here, so what's going on here? I've got a vector of horizontal points, or points along the horizontal axis, and this is points along the vertical axis. I'm saying fig comma ax is equal to plt dot subplots. Okay, so what is exactly going on there? Well, again, PLT, it says it's going to look in this library, pyplot, which is a sub-library of matplotlib, and it's going to call this function subplots. Okay, so subplots is just something. Subplots is just a thing that pyplot knows how to do. Okay, it's a coded function that somebody else coded for us that we get to use. And what it does, it's going to return a figure and an axis. Now, a figure, like we will see later on, that we can have multiple axes. We could have multiple graphs here. Like maybe here I want a graph of x squared. Here I want another graph of x cubed. Here I want a graph of sine of x, things like that. So the axis or axes is like this right here. And I could have another axis right here. If you don't put any information there, it just gives you one axis. And then the figure is the whole figure. So I might have an axis, a set of axes here, and a set of axes here, and the figure refers to everything. Okay, so plt.subplots, it returns a figure and an axis. I know a lot of this might be confusing now. It's best to just sort of, if you haven't done any programming before, it's best just to kind of look at some of the examples and get examples to work, and then see how you need to change things to do more interesting things. Okay, but let's say now I want to graph y equals x squared, and I want to graph this from -2 to 2. Or actually, let me say one more thing. So the way that this works is we say ax.plot. This means in this axis right here, we want to plot the x values and the y values. And the way it always is going to work is it's going to take the points, so 0, 1, 1, 3, and 5, 4, and then just draw the line that goes in between them. Okay, so now let's say what we want to do is we want to graph y is equal to x squared. Okay, now one way to do this, and let's say we want to go from -2 to 2. So I could say x is equal to -2, -1, whoops, -1, 0, 1, 2. Okay, so this is a pretty bad way to do what we want to do, but it's going to work. And the corresponding y values are 4, 1, 0, 1, 1, 2. And now I'm going to do exactly what I did up here. I'm going to say fig ax is equal to plt.subplots. And then, whoops. So I did this. I accidentally ran it, so I didn't have anything plotted there. So now I'm going to say ax.plot xy. And what this is doing is just going to do this plotting that we talked about before. So it's going to plot kind of, not a point, but like a dot at -2, 4, -1, 2, 0, 0, 1, 1, and 2, 2, and then it's going to connect all of those points with lines. So we're going to get like not exactly a parabola, we're going to look at a very like angular parabola, a line segment approximation to a parabola. Okay, so I'm not exactly sure where I was because I just was talking to some colleagues. Okay, so what is this going to plot? It's going to put a point or a dot, like there's not actually a point here or a dot here, but it's like maybe light up the pixel at the point -2, 4, -1, 2, 0, 0, 1, 1, 2, 2, and then connect all of those with a line segment. So this will be a very angular parabola when I run this. So if I run this, I get this. And now, hopefully, some of you saw the mistake that I made. This should not be a 2, that should be a 1. And that should not be a 2, that should be a 4. So this was completely by accident, but this actually is a good lesson here because I made a very basic error going from x to y doing the squaring. Now computers don't make the error, and that's one of the things that we like about computers because it will do tedious things without making errors. So now I made the change here. Let me run it, and this is what I get here. So it's a very angular parabola. Okay, well, so now the thing that we want to do is we want to make it a less angular parabola. So how can we make it a less angular parabola? We could do it by adding more points. So instead of -2, I could do, instead of going from -2 to -1, I could do -1.5 here. And here, I could do 1.5. And down here, I could do minus 1.5. The Python notation for square is double star 2. And then over here, I could have 1.5 square. Okay, and so now I'm going to run this, and we're going to get a less angular but still very line segmenty parabola. So I'm going to run this. Okay, again, it looks more like a parabola. And then if I wanted to do this even more, let's say, instead of going from -1 to 0, I could have a minus 0.5. And then I could have a 0.5. And then down here, I would have to add a minus 0.5 squared. And then here, I could have a 0.5 squared. And I could run this. And now, okay, well, I messed that up. Okay, I forgot the comma there. Okay, and now this looks, okay, and we can see how I can make this look better and better and better if I make a finer and finer X thing here. Okay, now clearly, this is not, as soon as you're doing programming and you find yourself doing something like this, where you're just writing out a whole bunch of very tedious things, there should be an alarm bell going off saying there's a better way to do this. And there is a better way to do this. We're going to look at a better way to do this in the next video, and we're going to use a library called NumPy. Yeah, okay, so we're going to do that in the next video.